Hi there, Nicole. All right, so let's take a look at an example. On the bottom of the screen, you can see an example of a weighted average question. We've got 333 men, 222 women. The average age of the men in the group is 30. The average age of the women, 20. What is the average age of everyone in the group? Okay, so the first thing that most people think of when they go to solve a weighted average question is the simple weighted average formula. Okay, and in the case of this problem, it would actually work quite well. The weighted average formula, instead of taking the two stats and adding them up and dividing by 2, has you take each stat and multiply it by a weight. So, for example, the men's stat of average age of 30 would get multiplied by the weight, which is the number of men, 333. The women's stat of 20 would get multiplied by their weight of 222, and then you would divide by the sum of the weights. The truth is, though, that you really only need the ratio of the weights. You don't actually need to work with these gargantuan numbers. Okay, so you could take the fact that 333 and 222 is in a 3-to-2 ratio and simply multiply the 30 stat by the 3, the 20 by the 2, and divide by the sum of the weights. Okay, if you worked with weighted averages before, this is probably pretty straightforward for you. In this case, you're going to come up with the answer of 26. Now, when we talk about a weighted average problem, it's helpful, as is the case with most GMAT questions, that you identify the elements that are part of the story. Okay, and we can think of, when we look at this example A, we can think of there as being sort of 3 elements that make this a weighted average problem. Number 1, the 2 statistics. So we have the average age of the men, the average age of the women. Number 2 element would be the weight ratio, okay, which in the case of that problem with the 333 and the 222 was 3-to-2. And lastly, we have the weighted average itself, which came out to 26. Okay, now obviously you're not going to be given all of these elements because then there would be no problem to solve. Okay, but what you will find is that one of the elements will likely be missing. Okay, now in the case of when they ask you to find the weighted average, usually the easiest way to go about solving the problem is to use the formula that I just showed you. Okay, so if you're armed with the 2 statistics and the weight ratio, then you can use the formula to solve for the weighted average. And that's what we did. We took the 30 and the 20, combined with the 3-to-2 ratio, 3-to-2, multiplied each by its corresponding weight, and divided by the sum of the weights. Okay, now, unfortunately, or perhaps we should say fortunately, most of the time on the GMAT, weighted average questions are not given to you in this way. Okay, they're what I would call backwards weighted average questions. And that's the most common presentation of a weighted average question on the GMAT, a backwards question. Now, what's a backwards question going to look like? Well, example B here, let's take the same data that we were working with in the example A, only let's turn it into a backwards weighted average question. So we have the average age of the men in the group of 30 again, and the average age of the women is 20. And we also know the average age of everyone in the group. So we've been given the weighted average this time of 26, and we're being asked for the weight ratio. Okay, so if we looked at that kind of graphically or schematically, We have the two stats. We have the weighted average. Go down. There we go. We have the weighted average, and we can use something that I refer to as the distance method to find the weight ratio. And this is the punchline of the session here this evening or this afternoon, whatever it is, your time of day. It's evening by me. This is kind of what I really want to get to, because this is the sort of really cool method that allows you to solve weighted average problems, the majority of weighted average problems, very quickly on the GMAT. So what is this distance method all about? Okay, so the way it works is you place the two stats, the men's average and the women's average are the two stats, remind you, and the weighted average on a number line. Okay, and you simply measure the distance that the weighted average sits from each of the two stats. 26 is 4 away from the men's 30 and 6 away from the women's 20. Now, the cool part, you guys will get a kick out of this, is that the ratio of those distances, in this case, 6 and 4 reduced, let's say, to 3 to 2, is the actual weight ratio of the two parts. In other words, because 26 is 6 away from the women and 4 away from the men and women are in a 3 to 2 weight ratio. Now, one little thing that's of note is that it inverts, okay? In other words, the 3, the larger number, in this case, in the weight ratio, the 3 to 2, goes to the men because, as you'll notice, the men are actually closer to the weighted average than the women. So don't be confused by the fact that this distance of 4 reduces down to 2, and why are the men not under the 2? Why are they under the 3? Because it actually gets inverted. But I don't even recommend that you remember that it inverts. I just recommend that you use your logic when it comes to this. Simply calculate the distances. 26 is 4 from one end, 6 from the other. Reduce the ratio, 3 to 2, and then use your logic to assign which is which. The logic dictates that the men will get the bigger value since the weighted average is closer to the men's stat. Let me say that again. The men will get the larger value in the weight ratio, in this case, the 3, because the men's stat is closer to the weighted average. You can kind of think of it as like a tug of war, that game we used to play when we were kids with the rope, where you pull to try to get the flag or whatever, closer to you. The heavier side, the side that is more heavily weighted, will pull the weighted average closer to it and will therefore need to be given the higher weight. Any questions so far? This is pretty clear. For whom, I guess just from the 4 of you, because I don't know who's listening on the people who are off camera. For whom is this kind of new that actually you can get the ratio by calculating the distances? Give me a hands up, or for 2 of you, it's new. Okay. All right. Well, that's something. And that's usually about the case, that like half or so of people don't know that you can do this. I didn't know that you could do this when I first looked at weighted average questions. Okay. The fun part now is that we can see how this will be applicable in all kinds of situations. So for starters, in the backwards weighted average question, you can be asked a myriad of different questions. For example, the one I gave you, it said, what is the ratio of men to women? Okay, and the ratio of men to women, we said, was 3 to 2. Okay, now, from this weight ratio, there's a bunch of questions that the GMAT can ask you and that you can answer. For example, what percent of the group is female? That would be the women's 2 over 3 plus 2, 2 out of 5, or 40%. What percent of the group is male? 3 over 3 plus 2, or 3 over 5, 60%. The number of men is what percent greater than the number of women? You could use the 3 and 2 ratio to do a 3 minus 2 over 2% change for 50%. So there's a variety of different things that they can ask. Don't be alarmed when you see the question doesn't say what is the ratio of blank to blank, but it gives you one of these percent questions. Remember that it's a derivative of the weight ratio and that the question is a backwards weighted average question, and that you can use the distance method to find the ratio and to then answer the question. Okay, assuming that it's problem solving. If it's data sufficiency, you can just say, I can find it and move on. Okay, any questions? Okay, so one of the hardest parts, probably the hardest part of applying this on the GMAT is recognizing the opportunity to do so, okay? Because it's not always patently obvious that you have a weighted average question or a backwards weighted average question that you can use the distance method for, okay? It is obvious when you have the statistics are both averages. Okay, so when you have the average age of men and the average age of women, and then you have the average age of everyone, that one kind of everyone knows. Okay, but when we get statistics that are of a different nature, it usually isn't very obvious. The two conditions that we want to look out for to recognize that we have a weighted average question on our hand, perhaps a backwards one, likely, are, number one, the problem mentions a breakdown of two parts that sum to a whole. So they have, for example, male, female, and then everyone. Cars, trucks, cars and trucks together. Part A, part B, part A and B together. Water, alcohol, the mixture of the two. Mixture questions tend to be weighted average questions. Okay, that's number one. And by the way, this breakdown of part to whole shows up in another question, which definitely is a question type by GMAT's criteria. Can anyone think of a place where we always have part, and then a whole? I'll give you a hint. When you solve it, you've got the two columns sum to the third column and the two rows sum to the third row. What kind of question is that?
Catching a problem, mixture problem, dry mixture problem.
Okay, mixture problems. Yeah, that wasn't what I was driving at, though.
No, even catching up, like when you are calculating distance.
Okay, yeah, but you don't sum the rows and columns for a distance thing. You multiply, right? Rate times time equals distance. My son is curious. He wants to join in the lesson. Okay. Overlapping sets. Okay, overlapping set problems always have a breakdown like that. And there's an overlap, pun intended, between overlapping set questions and weighted average questions sometimes. And if you have the opportunity to use a weighted average solution, it'll be much faster than filling out the full matrix. Okay, anyway, the first criterion is a breakdown part whole. The second criterion is that there's a common statistic mentioned for each part and for the whole. Okay, what's a common statistic? A percent. For example, you could have percent profit. You could have two portfolios, like part A, part B, and A and B together, and there's a percent profit for for A, for B, and for the overall. You can have a percent increase, a percent decrease, a percent concentration. It can be a unit cost or unit weight. It can even be a rate. Okay, although average rate questions, which are weighted averages, tend to be solvable in another method, using another method, total distance over total time. And usually those questions lend themselves a little bit more readily to that solution rather than to what I'm showing you. If it comes the way in a package that the weighted average solution works, then it's great, but they often don't. Okay. So here are some examples of what I mean when I say a common statistic. So let's say you were dealing with cashews plus almonds. Okay, the common statistic in that case would be the price per pound. Okay, so it's a mixture problem, and you have a price per pound for the cashews, for the almonds, for the cashews plus almonds. Okay, another mixture. Let's say you have A, B, and A plus B. Okay, and let's say we're talking about alcohol, where you're making a mixture. Okay, and you have percent alcohol in A, in B, and then percent alcohol in the combination. Cars plus trucks, percent increase in revenue. Okay, and you guys can read the rest of the examples. I won't read through all of them. You might want to take a screenshot of that, though, because that's in general. In fact, let me do that for you so that you can see it all on one screen. This is how you're going to recognize that you're dealing with a weighted average problem. And again, the questions that are of this nature, my feeling is that GMAT doesn't classify them as weighted averages. They classify them as mixture percent problems, as rate questions, as percent, general percent questions. Okay, and before you know it, you have 3 or 4 questions on one test that all have weighted averages, and they're all in different topics, so to speak, but you can use the same strategy. So this is why I made a session on this tonight, because it's such an important topic. It can show up in so many different places. It can show up in the IR, and those of you, it almost inevitably will show up in IR. Those of you who are are switching over to GMAT Focus, how many of you are doing GMAT Focus? Okay, no, you're still trying to get in under the wire for the. That was an emphatic no there, Patrick. Like, no, don't take my sentence correction away from me. I want sentence correction. No, what's wrong with me?
Like a half year ago, I didn't want to have a sentence correction, but now I've put so much energy and so much time into sentence correction and all this stuff. So I definitely take the old fashioned GMAT version.
The legacy, right? They're calling it. So you got until January 31st. So make sure you
I know.
Of the time. Yeah, I'm actually very sad to see sentence correction go, but I like grammar. So what can you do? All right. So let's talk a little bit about using this concept. Let's do a problem. Okay, go ahead and take couple minutes to do that problem. It's a DS question, obviously. Okay, so those of you who are on camera, you can use by way of finger vote, A, B, C, D, E, just hold up the number of fingers that you think corresponds to the right answer. So 3 is C, right, Patrick? Just to be clear. Okay, letter C.
I didn't do it yet though. Sorry.
You didn't what?
I didn't do it yet, but
You didn't do it
could
out fully. That's just your initial.
Yeah, because I started talking to someone.
Oh,
Sorry.
okay. That's okay. I'm putting you guys on the spot.
Yeah, but honestly, I would correct myself to B.
To B. That's a good correction.
I know.
Yeah, that's a good
that's why
correction.
I do it. That's why I did it.
Okay. So yeah, what we're dealing with here is we've got our two stats is the X price of 212K. Oops, that's off the screen. The Y stat of 194K. And then the average of the assessed values of the X plus Y houses is asking us to find the weighted average of the two groups of houses, of the X and the Y, the X group and the Y group summed together. Okay, now this is not a backwards weighted average question, but it's a data sufficiency question, so it's immaterial. Okay. Remember what we said we needed in order to find the weighted average. We needed the two stats and the weight ratio in order to find the weighted average. And then we could use the formula. Okay. And that's the punchline here, is that we need the ratio, which statement 2 gives us, right? Statement 2 gives us the X to XY ratio. This would never be C, this problem. This is a classic case of a C trap. Obviously, with the two statements together, you can find X and Y, right? Because you have two equations with two unknowns, but that's too easy. And when C is too easy like that, that's what we call a C trap. Don't put C, put A or B or D, or try very hard to put one of those. Okay. Okay, now I'm going to give you a problem that I want to warn you. If you try to do this with the weighted average formula, you're never going to get done in 2 minutes. Okay, I'm only going to give you 2 minutes. I'm going to set a timer. Okay, and I would urge you to try and use the distance formula, do something with it as a backwards weighted average question. Even though it doesn't seem like it is a backwards weighted average question, it's because it's problem solving and you have answer choices. Hint, hint, you can make it into a backwards weighted average question. Okay, ready? Go. 2 minutes. Okay, that's 2 minutes. Okay, so those of you on camera can use the same polling with your fingers. Let me actually open this one up also to the chat. Those of you who are not on camera, just send in an answer by way of the chat. Okay. All right, so this one is really hard to do out with full-on calculations. Okay, the calculation, if you were to do it, would look something like this. Okay, this would be the formula. The weighted average is 35. Okay, that's for everyone. The 26 is the women's stat. The 26 is weighted. Sorry, back up. The 26 is the weight. It's the number of women. The 22 is the number of men. So those are the weights. The men's stat is 38. That's their average age. The women's stat is unknown. That's what's unknown to us, the average age of the women. And the 48 is the sum of the two weights. It's the 26 plus the 22. Okay, now if I wanted to, I could have plugged in here reduced ratio of 13 and 11 and 24 on the bottom. I don't know if that would have made a huge difference. It doesn't reduce the ratio by that much. So where's the pain? I mean, why not just use the formula and finish the problem this way? Well, in the calculator-free GMAT, except unless this showed up on the new data interpretation section, where you do have a calculator on GMAT Focus. If this were on the regular section and you don't have a calculator, you have 3 painful calculations here. You have 35 times 48. You got to go do the math on that. 22 times 38. You got to go do the math on that. Subtract that from the 35 times 48. You got to do the math on that. Divide by 26. You got to do the math on that. That's 4 painful calculations. Did anyone actually do that in 2 minutes? I have a feeling one of you is going to say that you did. No? No. I knew it. I was looking at you, Steve, and I'm like, come on, fess up.
Almost 2 minutes, not properly.
What?
I just get more confidence while calculating. I have tried this method earlier, but it's just high school. It is ingrained, so I have to use calculation. So I have full
Well,
confidence
some
in
of
my
you
answer.
folks over in, I assume you're in India, just from your name and your accent, please correct me if I'm wrong.
Yeah. Right now
Okay.
I'm in Dubai. I'm working here. So yeah,
Yeah.
basically
Oh,
from
okay.
India. Yeah.
Yeah, you're from India. Yeah, I mean, you guys learned in school to do calculations at some pretty fast speeds, compared to, you know, the average student from the States. And so I would say that this is nearly impossible for most people to finish in 2 minutes. And I think you went over, actually, if I'm not mistaken, by about 30 to 40 seconds as well. Okay, and that was part of the point that I wanted to make on this question. I mean, yeah, if you want to do the calculations and spend 3-4 minutes on this problem, no problem, you can do it. Okay, but instead, we can consider the answer choices and think about this question as a backwards question by using the answer choices. The answer choice that's got my attention, make this a little bit smaller, is the 32. Why does that have my attention? Hopefully that's not too small.
split.
Can you guys still see this? Okay, Patrick, I didn't mean to cut you off. Go ahead. What were you saying?
Yeah, because it's a 50-50 split, so it's straight in the middle of all the answer choices.
Right. Okay. Okay. It's in the middle of the answer choices, but it also, the 32 would be what the women's stat would be if the weighting were 1-to-1, right? That's what you meant by the 50-50.
Yeah.
I think.
Yeah.
Okay. Exactly. So if there were an equal number of men and women, the 32 would be our guy, because 32 is 3 away from 35, as is 38 3 away from 35. Okay, now we know that that's not the case, because we know that the women male-female ratio is not 1-to-1. Okay, notice also that this problem asked for the closest. Okay, it asked you to approximate to some degree. So we're going to do some approximating here to get to our right answer. The fact that the women are more numerous than the men, 26 women, 22 men, means that we would want the women to be closer to the weighted average or farther away. What do you guys think?
Closer.
Closer, that's what we learned, right? Closer. And so our answer should be bigger than 32 or smaller than 32?
Bigger.
Bigger, that's right, Jacqueline, because if it's bigger than 32, the distance from 35 will be smaller, and that's what we want. We want a smaller distance. Okay, now all that remains to do is to test D and E to see which one is closest, is going to give a ratio of distances that's closest to the weight ratio of the problem. Okay, so let me do this over on the side here. Let's do the 32.5, the 30, getting ahead of myself, the 35 and the 38. That would be distances of 2, 5, and 3. And then if it's the 33, 35, 38, then it would be distances of 2 and 3. So the question is, do we want a 2.5 to 3 ratio, or do we want a 2 to 3 ratio? Okay, and so let's just have you guys vote, those of you again on camera. One finger if you want the first one, the 2.5 to 3 ratio. 2 fingers if you want the 2 to 3 ratio. Which one do you think is closer to the weight ratio that we were given of 13 to 11? Right, we were given 26 to 22. So you're voting here. Yeah, okay. So you guys all can see here that the 2.5 to 3 is much closer to the 1311. Okay, in fact, if you multiply this by 4, this comes out to 10 to 12. That's very close to 11 to 13. That's very close. This would be, if you multiply it by 4, 8 to 12. That's very far away from 11 to 13. Okay, so the answer is D dog. Any questions? And you could do this in less than 2 minutes. Obviously, I was explaining and all of that, but if you have your head about you and you really understand the method, you can definitely do this in less than 2 minutes. Any questions?
I have a small question. So before starting, you were saying like, I tried to do it by the distance, but later, like while thinking like how to do it, I was like, it's better to do it through the calculation, because here we are doing approximation. In case if there is any other question in which between like 32 and 33, 30, if there is one more option, which
They
is
won't have that. I
32.4.
know where you're going with this. Like that the distances, like the approximation will be too close, right?
Yeah.
Is that what you're saying? They won't
Yeah.
have it like that. I'm telling you, this works like a charm on every weighted average question I've ever seen in 20 plus years of looking at the GMAT.
That's
Look,
perfect then.
you can do the formula. I'm not going to tell you no.
Yeah.
Okay. And in a case like in your situation, like, okay, you only spent like 230, 240. I was watching you on the problem. That's not the end of the world, okay, on one problem. Okay, I don't think that I could do the long multiplication slash subtraction slash division, all of those, in under 3 minutes, personally. I don't think I could. I saw that you did. That's great.
No, this sounds that's. I think if the options won't be like tricky, then I think this is way better than rather than
Yeah, no, it is way
calculating.
better. It's for
Yeah.
sure way better. I promise you. I wouldn't be teaching it to you otherwise. I wouldn't have made a webinar on it. You know, you can make a webinar on lots of things, but one that can fill an hour is going to be something that's actually got some meat on its bones.
I have a question.
Please.
So just to double check, like if you got to the point where you see 2.5, 3, and 2 and 3, 2 to 3, and you're not sure which one is closer to 11 to 13, you could just then do that math, right? And just compare.
Yeah, the math that I showed there was to get closer to the ratio. Use some sort of multiplier to get the two, because 2.5 to 3, you might look at that and go like, I don't understand what that is. Let me multiply by 4, because the 3 times 4 will be 12, and that will be close to 13. So that was my rationale. Does that make sense? To kind of get in the neighborhood so that I could see, oh, 10 to 12, 11 to 13. That's a really close ratio. Do you understand why 10 to 12 and 11 to 13 is so close? Because 10 12s, all you have to do is add 1 to the numerator and the denominator. And that doesn't affect fractions that much when you add 1, like when they're above a certain amount. When fractions are, you know, when they're not the first few fractions, like a half, and I'm not explaining that very well, but when the number is so close to whole to 1, 10 over 12, like when you add 1 to numerator and denominator, it doesn't affect the fraction that much.
Okay, sounds good. Yeah, that makes sense.
Okay.
Thank you.
Another way to look at it, which is kind of another option, is 2.5 to 3. You can think about it in terms of percents. Like 3 is what percent greater than 2.5? 3 is what percent greater than 2.5? So it's 0.5 greater, right? And 0.5 out of 2.5 is 20%. So 3 is 20% greater than 2.5. And 13 is what percent greater than 11? It's 2 greater. 2 out of 11 is around 20%. 2 out of 10 is 20%. So that's another way to see that. And then 3 is what percent greater than 2? Oh boy, that's 50% greater. That's not even close. So some people prefer that way of comparing ratios. Okay, I'm going to go over a little bit since I was so on time today. Hopefully that's okay with you guys. If you need to drop out, I won't be offended. I hope you enjoyed the webinar. Okay, so the next thing that I want to talk about is when you really start to spot this and use it, you might run into a little bit of a pickle in one place. And let me talk about what that one place is. So let's give an example of 2 portfolios. Portfolio A yields a 7% return on investment. Portfolio B yields a 15% return on investment. If together the 2 portfolios yield a 9% return on investment, what does that tell you about the 2 portfolios? Okay, obviously that's not a GMAT question, the way it's open-ended like that, but I asked it like this so that we can discuss what the units of the weight ratio are. How can you determine the units of the weight ratio? Okay, the question is definitely a weighted average. It gives us breakdown into 2 parts, A, B, and A plus B. And then it gives us a common statistic, right? A percent return on investment. because it's backwards weighted average question, it gives us the weighted average. The 9 is the weighted average. It's best to use the number line method. So we use 9 in between 7 and 15. It gives us a ratio of distances of 2 and 6, which when reduced, of course, would be 1 to 3. And I showed you really quickly, but I made it disappear. It would favor which one? Would it favor, which one would be the 3, the larger number, the B or the A?
A.
A.
Right, exactly, A, because A is closer to the weighted average. Okay, and so A would be the heavier of the two elements. Now the question is, great, so A to B is 3 to 1. 3 to 1 what? Like 3 what for every 1 what? That's what this whole slide is about. Like, how do you know what units the weight ratio is in? Like what you're finding the ratio of. So what do you guys think it would be here?
The return on investment.
The return on investment. So are you saying you'd have 3 times as much return on investment for
The
portfolio A?
principal amount, I think.
Okay, we have another vote there. And Kushdeep, what did you say, Kushdeep? Repeat it.
So you're saying what's the ratio, right? If I'm not wrong.
Say that again.
So you're asking like what's the ratio represent? Like if
Yeah,
there's a
right.
question.
Right. I think you gave the right answer. Just repeat what you said though.
Principal amount, like what was
Yeah,
the principal?
it would be the principal amount that was invested in A and B. Okay, and how do we know what it is? Because this can get a little bit, this is one place where the method can get a little bit confusing. It's the principal amount of invested in A and B, meaning there's 3 times as many dollars or whatever the currency invested in A as there was in B. And that's why it came out closer to A, the return. Okay, now how can we tell what the unit is? There's an easy way to test it. Whatever the natural multiplier of the statistics is what the unit is that you're dealing with for the weight ratio. The natural multiplier. So when you think of a percent return, the percent return gets multiplied by what? 7% return gets multiplied by what? By principal. Okay? So it's got to be the principal that is what the weight ratio is of. It's the ratio of the two principals. Okay, let's give you another example. Let's say you had, this is actually one I've definitely seen on the GMAT more than once. Let's say you have, I don't have it written up, I'm just going to give it orally. Let's say you have, well, I can write it. Hard to take something. Let's take a nice hybrid economical car. Miles per gallon. Okay, this is the city. This is the highway. And let's say that this person does on average 48. This is the combination. City plus highway. Now that means that the person drives more on the highway, obviously, and it's in a 8 to 2, 4 to 1 ratio. So what unit is represented here? What is 4 times the value of what? I mean, the city, the highway something is 4 times the value of the city something, but what is that something?
Miles? No?
I got you on this one. Okay, the stats are what? What are the stats? They're 40 and 60 and 50, excuse me.
Miles per hour.
Miles per gallon. Yeah, you don't know about that in in Germany, Patrick, because you do liters per 100 kilometers, right?
Yeah.
Yeah, it's the same here in Cyprus, but miles per gallon is fuel efficiency. That's how it's measured in the States. What is the natural multiplier? Remember, whatever you would naturally multiply the stat by is what the weight ratio unit is in. So looking at this unit, miles per gallon, what are you going to multiply by to get something else? The key's in the unit. It tells you everything you need to know.
Gallons?
Gallons. And then you'll get miles from that. So actually what this is saying is that Joe, whoever this is, Joe Schmo, he is driving on the highway 4 times as many gallons of fuel. He's burning 4 times as many gallons of fuel on the highway as he is in the city. Okay, so it's whatever the natural multiplier of the stat is. That's what the weight ratio's unit is in. If they asked you for the miles ratio, you'd be in trouble here. Well, you'd have to go through another calculation, so you wouldn't be in trouble, but you'd have to go through another calculation. Okay. As a sort of bonus for you guys to work on at home, I've got some problems that you can take screenshots of, and you can take some screenshots of the answers, because we're coming. I mean, I've gone 10 minutes over, and I know I started about 15 minutes late, but I don't want to keep you guys here all day or all night. I think that this is a logical stopping point. Let me just put the screens up. So I've got 12 problems that you can work on. Okay, and then the last screen will have the answers for all 12. So just here's the first set of 4. Just take a screenshot. Give me a thumbs up when you're ready to go. Okay, I assume that our folks off camera are okay based on the average time that took. Okay, next set of 4. Oh, wow. You got the virtual thumb up there, Patrick. I didn't see it. It's even like dancing. That's okay. I was looking for something else. Last set of 4, excuse me. And the answers to the 3 sets. Okay, I will put in one final pitch. Part of the purpose of us doing this webinar, I mean, TTP does lots of free webinars just to help educate its student population, but was for you guys to get a sense of my personal teaching style, because I just started a class last night, a LiveTeach class. If you guys are interested in joining a LiveTeach class, you can still join my class. It would just be a week late. The time on the class is 1 to 4 p.m. East Coast time on Sundays. So it's a nice weekend class, once a week for 13 weeks. And you have a recording for the first session that you could make up for what you missed last night or yesterday. So that's an option for some of you, perhaps. I'm happy to hang around and answer any questions. Thank you all for your participation. Hope this was useful.
Absolutely. Thanks so much.
You're very, very welcome, Patrick. Thanks for attending.
Thank you so much for taking time out. And once again, it was great session.
All right, awesome. Hi, Jacqueline. You want to say
So I have
goodbye?
one question. So the same thing is in Manhattan Prep also, right? The distance thing,
The
which we did.
Manhattan Prep. The reason why
Yeah.
they put that in that strategy guide is because of me.
Uh,
It's a funny story. I didn't write the section because I had a broken arm at the time, so I couldn't but I sat there with the guy who took notes. I said, put this in. This needs to be in the strategy guide. So
yeah, I
yes,
remember doing it 2 years ago when I was preparing for like MIM, but I got the job, then I delayed it like for my MBA then. Now I've started it using TTP.
got it.
I will leave. See you around.
Okay. All
And have a
right.
nice evening back down there in Cyprus.
Yeah, you two up there in Germany. Where are you in Germany?
Frankfurt.
In
Frankfurt.
Frankfurt. Okay.
Yeah.
My sister-in-law is in Essen.
Okay. Yeah.
She's married to an Essenite. I don't know what you'd call that. Someone from Essen.
Yeah. As I don't know. I have never thought about that.
Yeah.
Probably Essen. Essen, no? I don't know.
I thought German has all kinds of funny nouns. Like there's got to be a word, right?
Yeah, probably yes. But I don't actually know what. I haven't thought about it. Esse? No, probably not. Probably more like Essener.
All
In
right.
German, it would be probably Essener or something like that.
If you did it in English, you'd probably call him an Essenite, like because it ends in an N, so they would add ITE probably, which sounds really
Yeah.
funny.
And we would probably add ER at the end or ERIN
Uh-huh.
for the female.
Oh, I see. Very interesting. Okay, well, thanks for your participation. Take care. Have a good rest of your night, Patrick.
Yeah, you too. Bye-bye.
Bye-bye.
So I have different topic, some doubt, you can say. So you know the absolute value questions. So
Yeah,
it
sure.
can be like you need to tell minus plus or like that. So I'm bit in that topic specific. I'm bit of struggling relative to other topics.
It's a
So
hard topic. Yeah.
yeah, so sometimes, especially in data sufficiency questions.
Mm-hmm.
So in that it's a bit difficult. So
Take the focus and you won't have ones like that.
no, in focus it's coming.
Absolute value, data sufficiency you shouldn't have. Because well, actually, if it's a positive negative question, you could have,
Exactly.
right. Okay, yeah. Then you could have it because then it's number properties and not pure algebra.
Yeah.
Usually the advice I give on that, Kushdeep, is to test cases. Just to test numbers, not to mess around with the algebra on absolute value.
Sometimes it takes time. So that's what, especially in the data sufficiency, it takes more than 2 minutes for me because it's very difficult for each case. You need to verify that.
Yeah, it's true. You do. But there's not much you can do about that.
Yeah. It's just practice.
Yeah.
And I think that's it for me. Thank you so much again.
Okay, you're very welcome. Have a good rest of your day.
You too.
Okay, if there are no other questions from anyone else, I'm gonna close out the room. And thanks again for attending.